So I'm Jim Dabney, and I'm going to be talking about the work that I've been doing with Sean Arthur at Virginia Tech on, this is the first stage of some work to develop techniques for doing V&V on systems that are developed using agile techniques for mission critical systems. So this is an overview of what I'm going to talk about. I'm going to talk first about the way that the context in which we've been doing V&V for a long time with conventional life cycles, and then I'll talk about Agile and just a brief overview of it, and then how it's being applied to mission critical systems, and then the work that we've done in comparing the V&V needs with what's available on these hybrid Agile systems, and then some comments on what needs to be done on developing some techniques for some of the important things that we do. So for a conventional mission critical life cycle, what we've been hearing about today, what we've been doing for flight software for a long time, but also for other kinds of mission critical systems such as medical devices, things that have to be have UL certification. Traditionally, it's been done with a sequence of life cycle stages represented as a waterfall. We'll look at the diagram in a minute, and a sequence of design reviews. And the names of them vary depending on the organization. The NASA groups typically call them PDR, CDR, and so forth, to design certification review. Large projects use an incremental kind of a model that can go on for a long time, which is a series of waterfall life cycles. So this is a diagram of a notional diagram of a traditional waterfall life cycle, what you would see in an old software engineering text. In the real world, nobody has ever developed software using a completely sequential approach because it wouldn't have a chance of working. I've seen organizations that actually tried to develop software using a rigid life cycle, and of course it's a disaster because it prevents you from learning about requirements once you get past the requirement stage and so forth. So it doesn't work, but the way that we do things is based on this kind of reasoning. So there's lots of diagrams that you'll see of humps in activity. We start doing test planning at the very outset of the project and so forth. But the key thing is that we do some kind of a sequence of requirements review. We saw in a couple presentations earlier today that the problem in the escalation of cost, if we find problems in software, particularly in requirements, as the life cycle proceeds. The standard goes up by 10 for each life cycle is probably not true, but it does go up a lot for each subsequent life cycle stage if you don't find a problem early in the life cycle. And so the V&V techniques that have evolved over the last 30 years or so take that into account and attempt to find things early so that they can be fixed when it's economical or even feasible. Large systems, the biggest example that I've worked on is the space shuttle use an incremental life cycle, which is a sequence of increments that each of the increments is a waterfall life cycle in itself. Typically for large projects, each of these increments might be 1 year long, give or take a few months. So they're a long time. They're not anything like the sprints that you see in an agile life cycle. And the planning is done a few increments in the future. Typically, the next increment is fairly well detailed, and the detail, of course, decreases the further in the future you're projecting. The conventional V&V process that's built around that life cycle is intended to reduce program risk by analyzing key artifacts. And as Ron said earlier today, that there's a movement to, at least at NASA, to go from a different perspective based on capabilities rather than analyzing artifacts. But even when you do that, you still have to look at the artifacts of the process to do verification and validation. Striving to find the issues in phase by mirroring the development effort. So the V&V team gets started almost at the same time that the project starts, stays in sync as the project unfolds. So in each life cycle phase, we're verifying that the product of that phase satisfies the requirements imposed on it by the previous stage. That requirements satisfy the user needs, that there's no unintentional functionality satisfied, the design satisfies the requirements, and then the testing fully covers the design and the requirements. So that process, that way of doing things, it works pretty well. It's been used for a long time, and the conventional software process is well suited to the needs of certification. But there's a lot of organizations that are going to Agile kinds of methods, and this is a standard diagram from an Agile tutorial on the reasoning behind the Agile. First of all, the core of it is the need to adapt to changes rapidly. So the Agile process is developed around Agile values, and then the principles that support that, and then finally Agile practices. There's not a specific Agile lifecycle. That one of the tenets of Agile is that the groups define their own process, and it even evolves for a particular group. So we can't say that there's a methodology that we can build a verification approach around. So one of the problems that we're going to face in dealing with this kind of a process is that the thing that we're doing V&V on the process is continuing to evolve. This is extracted from what's called the Agile Manifesto, which was written around 2001, and that's kind of the basis of the Agile approach is this Agile Manifesto. So the things on the left are the things that are valued more. The things on the right are things that are valued. So in the Agile Manifesto, what the people that sign on to that assert is that they although they value processes and tools, that they value individuals and interactions among the individuals more. And we'll see that in a minute in how things are done. A big problem for us doing verification and validation is, although the Agile Manifesto says that we value documentation, comprehensive documentation, that we value working software more. And that's probably the one thing that's the crux of the problem when you're trying to do V&V on Agile systems. We've got to have something to do V&V on. We can't just do V&V on code, because we need to know what it's supposed to do. And the documentation, the artifacts that tell us what it's supposed to do are things that are valued less and are therefore going to get less attention. The next is the interaction with the customer. And on the Agile Manifesto, it asserts that they value contract negotiation, but they value interaction with the customer, collaboration with the customer more. So the idea there is, instead of simply making a deal with the customer and then a negotiation is inherently a competitive sort of an interaction, to value more a collaborative interaction, in which often the customer is actually embedded, or a customer representative is embedded in the organization that's doing the development. Value following a plan, value more responding to change. And so this change welcoming of the Agile approach, very good if you're developing software to respond to very dynamic situations, such as consumer software. Not so good if you're trying to verify something, because it can change, and it can change after you've done verification activities. These are Agile principles that flow out of the Agile Manifesto. First of all, customer satisfaction is achieved by rapid, continuous delivery of useful software. So the idea there is that we want to get usable software in the hands of the users of the software very quickly, and then we'll update that and modify it as we need to. So that you have an iPhone, that's the way that you get the little notification that you have to update your software, and that's being done often in organizations that are using an Agile approach. So the working software is delivered frequently. We looked in a minute ago on the incremental model that's frequently used for flight software, releases every year. And on an Agile approach, you're doing releases every 6 weeks or even sooner. Late changes in requirements are welcomed, and we saw the expense in accommodating late changes. No, wait, how can we make it go back? I don't even have a mouse pointer. Oh my goodness, it's still on my screen, it's blank in there. So I'll just take a look here. So the late changes are welcomed in an Agile environment, and they're not at all in the way that we traditionally do things. Face-to-face conversation is the best form of communication. And so it's typical, as I said, to embed in an Agile team, to embed end users or the customer in the development team. If you're trying to do verification and validation of a mission-critical system, that becomes almost impossible. And it's certainly, you can't embed your V&V team in the development organization, and because you would be spread too thin. Continuous attention to total excellence sounds great, but there's not much we can do about that in terms of doing V&V. And then the self-organizing teams and the regular adaptation also challenges to doing V&V. Well, maybe this works. My computer seems to be disconnected from the... There we go. So this is a diagram of a traditional or of a normal Agile process in which you've got a product backlog, and then the backlog is decomposed into sprint backlogs that are worked in sprints that take usually 2 weeks. You see 2 to 4 on the slide, but generally it's 2 weeks. And then typically you're going to have 3 sprints to a release, so you get a release of your product every 6 weeks. So this slide shows we've got a product backlog that has, based on the architecture, the overall plan for the product, and then the sprints are divided into the product backlog, a set of features. The features are divided into a set of stories, which would be like one use case, and then those are going to be implemented a few at a time in each of the sprints. Do a few 3 sprints, and that gives you a release. Then that goes to the more usable software to the customer. One of the things that we often see is that there'll be 2 iterations, 2 sprints that are developing code, and then the third might be a cleanup kind of a sprint where we're doing integration and getting stuff ready to deliver. The original Agile wasn't intended for large mission-critical projects, and it doesn't work very well for those kinds of projects. This one of the Alistair Cockburn, one of the original people that signed the Agile Manifesto, said that it's good for small projects and exploratory projects, but it wouldn't work at all for NASA. But yet we've got NASA organizations that are trying to adapt it now, and they've modified it so that they can do that. Others comments as well on the inapplicability of the Agile methods to large mission-critical systems. So the standard Agile doesn't work for large mission-critical systems, but some of the benefits of Agile, the ability to adapt and to have a streamlined process, are very attractive. And so there's been an effort to develop Agile-like frameworks that use most of the characteristics of traditional processes, but also use Agile in the implementation part of the project. So the Scaled Agile framework is the most famous of those. It's developed by a private company, intended to be used for systems like medical and high assurance systems, certainly for aerospace systems. It would also be applicable, and that's the basis of the systems that we've seen. Another one is the incremental model from IBM, that it's based on a classical V verification, with and also intended for large mission critical and net-centric systems. The project that we've been looking at are using a SAFe-like variant of Agile that looks in the diagram much like an incremental process, but the difference is that instead of increments going on centers of a year, they're going on centers of about 6 weeks. So the early life cycle activities follow the standard process, and then the implementation is being done using the features and the stories and that sort of an Agile life cycle. And then certification has to follow the standard process, because we're maybe dealing with the Food and Drug Administration or underwriter laboratories, for example, and they're going to require whatever they require for certification. So we've been working on mapping the needs of the different verification and validation methods with what's available on that hybrid Agile life cycles. And we've gone through them looking for the three main elements: what inputs are required to do that analysis, when it's available, when those inputs are available, and the feasibility of doing those with the information that's in the hybrid Agile life cycles. And what we found is they fall into three classes: the early life cycle methods, for which it's fully compatible; methods involving tracing, which need to be tailored, but which works; and methods involving completeness, which are going to have to be replaced. So the early life cycle methods deal with analysis of concept documentation, security framework, safety requirements, and those are requirements-based things, and no significant changes needed in that. And that's a lot of the stuff that is done, but it's also stuff that's fairly easy to do. In the middle are tracing-oriented methods, and so those are things where there's a bi-directional trace from when a piece is implemented. I can trace it backwards to where it came from, the requirements for it came from. And things that fit into that would be fault trees, FEMA, and the testing, particularly unit testing and subsystem testing. So we heard from Scott this morning about the testing that they're doing on SLA, and that's a perfect example of something it does take tailoring to do it, but it's not that big a deal to develop an Agile, hybrid Agile variant that'll work. The final set of things are things that are completeness oriented, and these are things that deal with emergent properties. Rhonda mentioned this morning tracing fault management through a process. That's something that's often embedded in the whole system as it's developed, and it's fundamentally an end-to-end thing, and not something that I can do in pieces as I go. So that's something that is going to be challenging to do with a hybrid Agile system. Scenarios. One of the more valuable V&V techniques is tracing operational scenarios through a system. That's also, with the hybrid Agile processes that we've seen, very difficult to do, and not something that we can do until very late in the life cycle. So if we want to do those kinds of certification issues, we're either going to have to develop techniques that work like safety case techniques, sorts of things that work, that we can do incrementally, or wait until the end. And if we're doing things that are in the middle, like medical devices or UL certified kind of consumer products, we can probably just wait until the end to do that certification. If we're doing large mission critical systems, we're not going to be able to do that. And so new techniques are needed for those. Adjusting V&V to hybrid, the hybrid Agile, the first is project interfaces, and that is how we interface the IV&V team with the development team, or the V&V team with the development team. And the problem there is that in a traditional project, it's a very top-down military organization. In Agile systems, it's a very parallel organization, and so the coordination, the normal chain of command type of coordination doesn't work because there's not, that flow isn't even there. So we're going to have other kinds of project interfaces in which the V&V team can interact with the project without getting in the way of the project. And then also develop techniques to build assurance for the completeness of the emergent properties that I was just talking about. And so that's probably the biggest research issue, is that second bullet. So the conclusions, pure Agile is not going to work for mission critical systems. The hybrid Agile is being done, and it's going to be done more because of the productivity improvements that it offers. And then we're going to need to develop V&V methodology, particularly for those emergent properties. So my voice might make it to the end of a couple questions. So any questions?
Questions? Yeah. Okay, hold on. I know it's annoying, but there's a reason I do it, is that this is going out on YouTube. And we want to capture the questions as well. Who was Steve? When I break it, I have to pay for it. Thank you.
So I'm a little concerned about the assertion that you have to wait till the end of the process to do V&V. Why can't you simply map the requirements to the user stories, use a tool like Jira to manage your backlog, and then have your V&V team watch the stories so that when they come off the backlog, they can go find the developer and get in his shorts and then develop the V&V plan?
The two things that I just had on that last bullet, first of all, is the communications, to see what's going on. It's hard to do, and it's having an outsider coming around is a problem in that kind of a collaborative environment. And the second is that Rhonda talked earlier about the Q2 and Q3 kind of things. We're making sure that it doesn't do stuff that it's not supposed to do, and that it handles, that it works well in the face of faults. Those are things that as I go linearly through that, I can't see. And so that's the challenge, is to figure out ways to see that. I'm not saying that it can't be done, but it's not a simple matter of just looking at somebody's Jira tickets to do it. It's going to be hard to do.
No, I understand, but the whole premise of Agile, and I'm not necessarily a fan of Agile, is based on this collaboration, and you use the term outsider and don't have visibility. And until those problems are addressed, you're going to have as much problem with your Agile methodology as you do with your waterfall.
Oh, absolutely.
Okay.
Yeah, you bet.
Other questions?
Yep.
Oh, Jess, hold on.
In your conclusion there, your second to the last bullet, Agile projects may benefit from revised set of deliverables. Do you have a list of what those deliverables are?
Not that we're ready to release, but that's one of the challenges that we talked about. That's probably going to have to be negotiated on a project by project basis, and it's not guaranteed. Part of the problem with the V&V team is that we can't drive the developer to do stuff that we need for them to do, and so that's the challenge. It's going to be a negotiating process to get visibility. Even seeing the Jira tickets is hard to do.
Okay. Thank you.
So let me ask you, is there a collection of things you would like to have?
Say it again.
Is there a collection of products you would like to have?
Yeah, the things that we'd like to have are things that allow us to build the picture that we were just talking about. That's what we need to do, is for the V&V team to develop their own independent picture so that they can see where the project is flowing, so that they can be watching for those emergent properties. And so that's the instrumentation that we need, is to be able to have the visibility as it's going, to see where it's going.
Okay, thank you. Any other questions? Okay, thank you very much.
Thank you.